company, which is SkyCool with Ellie. Thank you.
So it's great to be here and see so many familiar faces. My name is Eli Goldstein. I am the CEO of SkyCool Systems. We got our start here in the electrical and mechanical engineering departments at Stanford. We've gotten support from the Tomcat Center and then received a number of grants from the Department of Energy RPE program. We are tackling essentially the energy use for air conditioning and refrigeration systems, and we can provide passive cooling for really any outdoor structure or outdoor surface. Our core technology is a thin film coating that, when it's exposed to the sky, will be cooler than the ambient air temperature. So even under direct sunlight, our material will be 5 or at most 10 degrees C cooler than the air. And what we're doing with this is using it, like I said, to reduce energy use for cooling. So we have 2 products, the first of which is the film itself, and we're applying it to outdoor surfaces. You could imagine on vehicles, outdoor electronics, using it to keep food cool by partially cooling it, similarly reducing stress on animals in farms, and then at the greatest scale is using it on buildings as a roofing material, again, to reduce heat islands. Our second product is a cooling panel, which you can see in the background of this image. This is a product on the roof of a commercial supermarket that we've shipped. But essentially, the panels are used to reduce energy use for air conditioning refrigeration systems. The product is deployed in the same way that you would do commercial solar. These panels will save about twice as much energy as a solar module, and similar in terms of scalability. We are working with commercial customers now to deploy them on roofs. If you'd like to learn more about the technology or our company, you can find me or go to our website at skycoolsystems.com. Thank you.
Hi, everyone. I'm Jana Colucci, and I'm the CEO and co-founder of Bundle, the enterprise marketplace for building materials procurement. I graduated from Stanford GSB in 2021, but before that spent 5 years working in design and construction in New York, where my eyes were open to how antiquated and fragmented the construction process still is. I really took that enlightenment and spent my time at business school really exploring the construction tech landscape. And I had come from the green building, healthy building space, which had only quite literally put up more walls when it came to building buildings. And so really thinking about how to impact this whole process, we've come upstream to really focus on the procurement process. What might be a staggering statistic is that 98% of construction projects finish over time and over budget, and procurement is a major cause of that. What happens with Bundle, however, is that our suppliers can come onto our managed marketplace and in their project management tools upload their product catalog, simplify their orders, upload pricing, lead time, sustainability information, so that when our builders come in on the other side and upload their bill of materials, they're able to get real-time pricing, lead times, sustainability information all in one place. They then check out through one vendor, us, as opposed to 300 or more. And then they can track where all their products are until they arrive at a job site. We're seeing our builders procure in 10% of the time and saving 10 to 20% in cost. And you may be asking, in this environment, what are we doing about carbon and climate? Well, we're doing a couple different things. First, by bringing transparency to the process, we're greatly eliminating construction waste, or greatly minimizing construction waste. We're also, through our embodied carbon tool, allowing project teams to set not only cost budgets, but also embodied carbon budgets, and with that real-time data coming in, allowing them to see what their impact is at any given point in time. And then lastly, our engine really is a managed marketplace, and our builders are able to resell products that they don't use on site, again, really coming back to that construction waste piece of the puzzle. We closed a pre-seed round last December. Since then, have launched our full product, grown a team, and just surpassed 1 million in annualized GMV, woohoo, a small but mighty milestone, and are starting to think about our seed round. So super excited to talk to you if you are interested in this space. We'll be down at the open house.
Hi, everyone. My name is Lizzie Kolar. I am co-founder and CEO of ScopeZero. I met my co-founder, Caitlin Highstreet, in a master's program at Stanford that's called Sustainable Design and Construction. It really focuses around energy-efficient building design. My background is in mechanical engineering, and my expertise is within residential utility consumption. Caitlin's expertise is within employee benefit fintech. So we basically combined our 2 backgrounds to create what we're working on at ScopeZero. So at ScopeZero, we created a new employee benefit called a carbon savings account, or a CSA. So with the CSA, we follow a simple and familiar employee benefit framework where you have the employee and the employer both contributing funds to the account. In our case, the employee uses the money for eligible home technology upgrades that reduce their utility bills and therefore their carbon footprint. So most of our eligible upgrades are home tech devices. You can also use your CSA for clean energy and clean transportation options. So our product is a platform that facilitates the benefit. We have 3 users, the employees, the employers, and a network of partner vendors. So this allows us to directly connect employees to the vendors to greatly reduce logistical burden, and then the vendors actually pass back a discount to the employees. So from the employee's perspective, if they have just a modest employer match and a modest partner vendor discount, they can now achieve quite an attractive ROI on their utility bill savings. So this enables us to structure the CSA as a financial wellness benefit, which greatly broadens our user base, as opposed to if we only targeted employees that want to lower their carbon footprint. For the employer, our platform measures all of the carbon emissions reduced from these CSA purchases, which actually directly reduce Scope 3 footprint. For any home tech upgrade, that reduces work from home emissions, and for any transportation upgrade, that reduces commute emissions. So we incorporated earlier this year. We've raised the majority of our pre-seed round, and we're going live with our first customers in early 2023. We ultimately have the potential to reduce residential utility bills within the US by $50 billion per year, which would be the equivalent of removing about 125 million cars from the road. So looking forward to meeting you. We'll have a booth in the back. Thank you.
Hello, it's a pleasure to be here. My name is Armel. I'm the co-founder and CEO of Kitswitch. We create modular apartment interiors to turn vacant buildings into homes, reducing both the cost and embodied carbon of multifamily developments. So they say that in life, change is the only constant. Yet as our needs have and will continue to evolve, our cities, buildings, and interior spaces are still being built in a way that is time-consuming, costly, bespoke, and most importantly, static. From this emerges parallel pain points, such as the fact that there are more than enough buildings to give everyone a home, yet vacancies increase while our housing crisis deepens. At Kitswitch, we create tools for housing developers, architects, and contractors to design for building flexibility. We offer adaptive reuse design packages, allowing architects to drag and drop 3D models from our digital library and instantly generate quotes and layouts. Our products are made with sustainable materials and produced through a network of local manufacturers, allowing their assembly to happen in parallel to on-site work while remaining close to the job site. Our modular apartments are delivered as a kit of parts, sized to fit through existing doorways and complete with pre-installed plumbing and electrical systems ready to connect to the building's supply through an easy-to-access panel. And most importantly, to our customers, our products install in 1 day instead of the weeks, if not months, required of traditional methods. And if the building use ever changes, our modules can be upgraded or reconfigured again and again and again. In our first year, we've manufactured full-scale prototypes. We've launched our first product line of plug-and-play kitchens. We've gained traction and secured letters of intent for over 200 apartments. In the coming month, we'll be opening our very own showroom in the heart of San Francisco, growing our team and rolling out pilots in partnership with affordable housing developers such as Habitat for Humanity. We're a women-owned startup founded by Stanford engineering graduates, envisioning a future where our cities can achieve greater circularity, where cities are built to better meet the needs of their communities, where our cities are built for change. Thank you. And don't forget to come say hi, my co-founder Candace and I.
Hello, my name is Capella Kirst, and I am the founder and CEO of geCKo Materials, the revolutionary bio-inspired adhesive company. I spun out my PhD here from Stanford a little over a year and a half ago, so it's quite an honor to be here on this stage speaking with you all today. Thank you so much for having us. You might be asking yourself, what is a revolutionary bio-inspired dry adhesive company doing at the Global Energy Forum? And that is an excellent question. geCKo Materials aims to help and has helped innovate across all industries manufacturing solutions for sustainable and energy-efficient solutions for any dry adhesive problems. This is geCKo Materials adhesive. It is mimicking the gecko's ability to climb up smooth vertical surfaces. geCKo Materials can be used 120,000 times. It is a whole life cycle process that is sustainable, green, and clean, while helping numerous industries. geCKo Materials has a shear strength of 120 kilopascals. What is that equivalent to? 1 square inch of this adhesive can support 15 pounds. 6 one-inch tiles can pull a car. geCKo Materials' first primary goal is to bring manufacturing back to the US. There are 800,000 US manufacturing companies with 300,000 manufacturing physical facilities here in the US. The primary use of dry adhesion in robot arms at these facilities is suction. Suction uses a very large vacuum pump. These vacuum pumps require large amounts of electricity as well as hazardous oils. You can do away with those large vacuum pumps, replacing those suctions with geCKo Materials adhesive, saving hundreds of millions of dollars in electricity bills per year per facility. For the other 500,000 companies, you can now bring your manufacturing back to the US in a sustainable, energy-efficient, clean manner. geCKo Materials can be used in any barometric environment, meaning it can be used here on Earth and also in vacuum or space. We're currently on the International Space Station. We're working with the Space Force, as well as numerous other space companies to help manufacture, again in an energy-efficient way, the next space frontier. We have used permanent, semi-permanent, and quick attachments for this next space frontier, and we're very excited for that realization of making this new, literally space in a clean environment from the get-go. I would love to speak with you at our booth located on the left side to help and talk to you about how geCKo Materials can help your company innovate while saving energy, time, and money. Thank you.
Good afternoon, everyone. My name is Anindita Banerjee. I'm the CEO and co-founder of Resource Chemical, where we are making the building block of next-generation plastic from CO2 and waste biomass that have superior performance than that of the fossil fuel-derived incumbents, but at the same time does not accumulate in our environments. Currently, commodity plastics account for a staggering 8% of global oil and gas and 4% of GHG emission. Bioplastics are a wonderful alternative to that. However, finding a technology that can produce bioplastic at commodity scale and produces a material that matches up in price and, very importantly, in performance with that of the incumbents has been extremely challenging. The plastics that can be made out of our building block, called FDCA, have superior properties than that of the incumbents. They have higher barrier towards gases like carbon dioxide, oxygen, and moisture that helps to increase shelf life of packaged food and beverages, keeping them fresh, flavorful for a longer time, reducing food waste. These plastics also have higher, superior thermal and mechanical properties that enables lightweighting as well as reusing the plastic, which is not feasible with that of the incumbents. The total available market of FDCA is over $200 billion, comprising of packaging, particularly food, beverages, as well as fibers for textiles. The chemical industry has, in fact, tried to commercialize FDCA for over 1.5 decades. all of our competitors are trying to make FDCA starting from glucose, which today is exclusively made from food sources. Aside from competing with food, the problem with glucose to FDCA route is that the chemistry of that is extremely complex, requiring some very challenging purification, separation, and resulting in poor to moderate yield of FDCA. We, on the other hand, are cutting down the process complexity by 70% compared to the state-of-the-art FDCA technology, which then lowers the capex for our commercial plant by a commensurate amount. Using CO2 and waste biomass as feedstock enables us to make a carbon-negative product with a GHG emission reduction potential of over 250 megaton per year without any land use change or biodiversity impaction, and saving over 7,000 petajoule of energy annually. Based in Berkeley, we are an early-stage startup company. We have received grants from National Science Foundation, Department of Energy, and have also received equity financing from VCs. Currently, we are optimizing our process steps in preparation of building and operating a fully integrated FDCA pilot plant. Our vision as a company is to make chemicals from carbon dioxide, but sustainably. We would love to talk to anyone who's interested to know more about our tech and is interested to talk about investment, partnerships, or is generally looking to understand our vision more thoroughly. We are at booth 10 in the showcase. Thank you, everyone, for your time, and happy to answer any question that you might have later.
Hello, everyone. My name is David Mechanic. I'm the founder and CEO of Anthro. Lithium-ion batteries are incredibly important today. And regardless of what sort of electronic device you're creating, people are generally trying to cram as many lithium-ion batteries in as possible. But today's batteries have serious limitations. They're bulky and rigid, which makes them pretty hard to design around. And perhaps more importantly, they're very unsafe, which leads to catastrophic battery fires in all sorts of applications. Today, batteries are a serious design hindrance, and the goal of going from cell directly to structure is impossible. At Anthro, we're developing batteries that are meant to be designed with rather than being designed around. To create these structurally invisible batteries, the key enabling technology is an advanced polymer electrolyte developed right here at Stanford University. This material has an unprecedented combination of mechanical strength and high performance. And by using it in lithium-ion batteries, we can impart some really remarkable properties. We create batteries that have extremely high mechanical integrity. They can withstand bending, flexing, impact, vibration, and all sorts of other disturbances. They're also incredibly safe. They can be punctured, they can be cut with scissors, they can be shredded in a shredder with very low to no chance of fire. By using these batteries, we can unlock a wide range of applications. This technology is also compatible with existing battery manufacturing techniques, allowing us to use it for cells of any size, any chemistry, for any application. Today, we're starting by creating these flexible batteries to provide unique solutions to manufacturers of wearables and medical devices. But in the future, we want to use this technology to impart structural integrity and safety into lithium-ion batteries for every application. We spun out of Stanford about 1.5 years ago, and we've already demonstrated our technology at 1 amp-hour level prototypes and have had our cells tested externally by customers and national labs. We're really grateful to have world-class support from our investors, government granting agencies, and Stanford University. At Anthro, we're changing the shape of energy storage, and we're putting batteries places they've never gone before. Thank you.
Hi, everyone. Thank you so much for being here. I'm Jorge Cordero, recent graduate of the School of Engineering and the Stanford School of Business, and I'm the co-founder and CEO of Magno Motors. I'll tell you a small story. I come from Mexico City. And Mexico, as most of developing economies, has a big problem in transportation. People need and depend on private vehicles. There's many factors that have contributed to this situation. Say insecurity on the streets, macroeconomics problems, such as inefficient transportation, public transportation, and even cultural paradigms that it's really difficult for these paradigms to change by 2050. People will still buying private transportation. And if we want to reach net zero emissions by 2050, we need to find a way to decrease the green premium of current green transportation over private gasoline cars for us to be able to decarbonize the countries that need it the most, developing economies. Right now, there's two options for transportation that is sustainable. First, there's really expensive vehicles that are unaffordable for the vast majority of the population. Second, there's also sustainable transportation that is still more expensive than the gasoline options. And the quality of these cars is really unsafe. Even though they are electric, they are severely inefficient. Just electrification is not going to solve the problem. At Magno Motors, we're building the first electric vehicle that behaves as a premium car. It comes with great energy efficiency. It comes with the correct and needed safety standards that we need in the region, has a great performance, and also a very attractive design, which is really important for customers to switch to an electric vehicle. And we are achieving these increments based on three main technologies that we are developing at Magno. First, a manufacturing system that is highly flexible and adaptable, that requires only 10 to 20% of the investment required by a normal manufacturing company. The second one, we're building a highly efficient vehicle that is low weight and also has high aerodynamic efficiency with a coefficient of drag close to 0.2. This allows us to have high range, but with a smaller battery than most of our competitors. And third, we're implementing our more than 4 years of research on autonomous and energy efficiency artificial intelligence and seamlessly integrating it into our vehicle, which helps us to increase the safety and the efficiency of the car. We're backed by the Stanford Tomcat Institute and the CEOs of automotive companies, composite manufacturers, and future of transportation consulting firms. We're super happy to talk to you at the booth, and thank you so much for coming.
Thank you, everyone. My name is David Jono. I'm the co-founder and CEO of AeroMutable. Do you know that about 4 out of every 5 things that you see in front of you were moved by trucks? In the US, this industry is responsible for moving goods from coast to coast, driving over 448 billion miles per year. It's arguably that this industry is the cornerstone not just of the US economy, but the world's economy. And unfortunately, when the semi-truck was introduced, really gas prices were cheap, and there wasn't a real awareness of the environmental damage that this industry causes. So particular emphasis was placed on the engine, making sure that it was big and strong. A cabin that's just comfortable enough for people to sit and drive anywhere between 8 and 11 hours per day. A trailer that's big enough to carry all sorts of goods from place to place, and a flat back to make it easy and efficient to be able to carry all those goods and to be able to load them and unload them. But nobody really thought about aerodynamic efficiency, and over 65% of the total energy used by these vehicles while driving on the highway goes towards aerodynamic drag. And the current solutions, well, they're not really cutting it. The trailer tails, the top kits, they're helping, but it's just not enough. In this space, AeroMutable can actually help. It's like getting a supercharger to a semi. Our patent-pending technology leverages our deep understanding of heavy vehicle aerodynamics, where our ability to sense the vehicle's surroundings, such that we're able to understand the environment around the vehicle and use our injection to change it, optimize it, and make it more efficient. The key to our technology is that we're able to really see what the vehicle is doing in real time and be able to really optimize its performance based on those real road conditions. We've been backed by the Tomcat Center, we've been backed by the National Science Foundation, the Department of Energy, and we have recently closed our first VC round. We're currently growing our team, and we would like to talk to you guys about our vision, about our product, as well as the path that we're taking to help the trucking industry reduce their carbon footprint while increasing their profitability. Thank you.
Hi, everyone. I'm founder and CEO of Zoom. I'm Ritu Narayan. At Zoom, we are modernizing student transportation. Student transportation is a problem hidden in plain sight. Pretty much all of us have faced it, but we don't realize it's an 80-year-old industry which has not changed at all. This industry is touched very little by technology. It doesn't meet the needs of today's families, why I got very passionate about this problem in the first place. And it is very highly underutilized and costly for the schools. On the flip side of it, it's a massive $28 billion industry. It's the largest mass transit system in the US, with 27 million kids traveling twice daily. There are 500,000 school buses on the road, and 99% of these buses run on diesel, and almost all of them are going to be electrified in the next few years. This industry is actually in a rapid shift because of two trends happening. One is digitization, where school districts and schools are demanding more flexibility, and the other is the climate change and sustainability. Zoom is actually leading these efforts to modernize this old, antiquated industry by doing three things. First thing, we have end-to-end cloud-based system which connect all the stakeholders and bring complete transparency to the system. We used to hear from the parents, we can track our pizza, but we have no idea where our children are. And now they can with Zoom. The second thing we do is, using our unique business model and technology, first, we reduce the number of assets needed to transport children. Second, we optimize the routes to save the commute time for students. And third, we actually improve the utilization of the assets. And third thing that we are doing in this space is we are actually building a playbook to transform this energy and transition it to sustainable assets on a very large scale. First, and we are not only building a playbook to transition the school buses to electric, we are actually also working with our partners in the ecosystem to bring electricity back to the grid. You'll be surprised to know that school bus is actually the largest battery on the wheels. It's almost like 8 Tesla batteries, and it's highly underutilized in the peak electricity demand hours. Just to give you an idea, our goal is to have around 10,000 electric buses on the platform by 2025, and if I were to connect all of them, it's equivalent to creating 1 gigawatt power of energy and lighting 1 million homes for 3 to 4 hours. Pretty impressive, right? So at this point, almost all the major school districts on the West Coast are using us, from Oakland, San Francisco, LA to Seattle. We have raised over $200 million of funding, and we are looking to bring the solution nationwide. We invite you to join in our journey in any form, as a partner in the ecosystem, as an investor, and I'll be around to answer the question. And finally, we are very passionate about this area because when student transportation works better, communities work better, and when communities work better, nations work better. Thank you.
And with that, we're wrapping up our final lightning round of startups. Thank you so much to all the entrepreneurs for the great presentations. Thanks for staying within the 3-minute time frame. I am impressed. And thanks to everyone for your attention until the very end.